This is a short supplement to the lecture that we had on N-Heterocyclic carbenes. There are several variants of the N-Heterocyclic carbene, although primarily the cyclic system having two nitrogens and an unsaturation in the ring system with a 5-membered ring is generally the most popular version. There are other variants to the N-Heterocyclic carbene. Let us just recap what we said about N-Heterocyclic carbenes. They are extremely popular these days because it is one of the most tunable ligands that are available in the literature today. In terms of both electronic and steric effects, one can vary the amount of electron density that you are pumping into the metal using this ligand, especially because it has got very good sigma donation capabilities. This ligand is unique among the various organometallic systems that we have studied so far. The pi acceptor ability is not significantly large, but the sigma donation can be improved tremendously. And as I said earlier, the ease of synthesis plays a very important role in the popularity of the ligand and in the usability of the ligand. So NHCs are in fact superheroes today. As I have talked about the classic N-Heterocyclic carbene, which has got a 6-pi electron aromatic ring system, there are variations of this, not just in the heteroatoms that can be present on the ring system, but there are variations in terms of the unsaturation that can be there in the ring system as well. Here is a saturated ring system, and that also is readily accessible from a diamine. And here I have shown you two ways by which you can prepare this N-Heterocyclic carbene, which is a saturated version and which is an extremely good electron donor. In fact, in this particular case, the increased saturation of the ring system makes the ring more electron donating, and so it's a better sigma donor than the ordinary N-Heterocyclic carbene. Notice there are two different ways by which you can achieve this ring system, and both of them are very easy to make and are very readily accessible. And so the saturated version is also something that is very popular in the literature. So the stable carbenes and their complexes are primarily the result of the steric protection that is there, the stability that is there through conjugation in the unsaturated version, and also the complexes are stabilized because of the small amount of pi acidity that is present in this carbene carbon. This is the unsaturated version, of course, and the classic N-Heterocyclic carbene, and that has the added stability of aromaticity. Now, in 2009, there was a very interesting paper, and the paper was about the abnormal carbene complexes. It turns out that the complexes that we have been studying so far are the classic carbene complexes, where the carbene carbon is situated between the two nitrogens of the ring system. And the donation of electron density from the sigma donor orbital of this carbene is leading to the formation of the complex. And of course, if I now block this carbene carbon with an R group and make a carbene in a different position, let's say the carbon which is not in between the two nitrogens but away from the two nitrogens, then I can also have a carbene. This carbene now has got very good sigma donation properties. It is still an aromatic system, and can have the stability associated with aromaticity. But nevertheless, the sigma donor orbital is in the plane of the ring system, and so it would be just a good donor as the other carbene that we have been talking about. In fact, it is likely to be a better donor because the electron withdrawing nitrogen is not present in one side of this N-heterocyclic carbene. This was indeed published by these authors, and the theoretical work was done by um, Gernot Franking, but this gentleman, Bertrand, was the person who discovered the abnormal N-heterocyclic carbene. And um, these two people, one of them is a student of Professor Jemis, who is in our department, and he was doing a postdoctoral fellowship with Gernot Franking, whom you have already met in another lecture. So these two people did the theory, and the experimental work was done by the French group led by Guy Bertrand. What they showed was that indeed it was possible to deprotonate the carbon which was bearing the hydrogen in the same imidazolil ring system, even if it was not situated between the two nitrogens. And you only needed a slightly stronger base. You need a slightly stronger base in order to do the deprotonation. And the same type of protection, steric protection that you had around the carbene carbon was sufficient. In fact, it could even be less. But you could make a metal carbene complex out of these. If you look at the type of bond distances that you have in these carbons, you find that the bond distances before and after deprotonation is hardly different, which is again a result of the aromaticity that is there in the pi system, which is perpendicular to the plane of the ring. The sigma bonds which are in the ring system are hardly affected by this pi bonding, and the sigma bond is the carbon hydrogen sigma bond is one which is disrupted and the one which is donated to the metal atom. Interestingly, it was possible to not just make a metal complex, but also this carbene carbon was now capable of adding carbon dioxide and forming a CO2 adduct. And that is just a matter of theoretical interest, but it tells you that it could, this is a carbene carbon. You can write it in the zwitterionic form, which we have done here, but you could also write it in a neutral form. And when you form an adduct with carbon dioxide, the zwitterionic form takes precedence because you can now stabilize the CO2 minus and the pi system, which is of course aromatic. And this would then be a more stable form, resonance form, that one can write for the abnormal carbene complex with carbon dioxide. The gold complex that is pictured above on the right top corner is the one that they characterized and showed that they are very similar to the regular N-heterocyclic carbenes. So let me end by just repeating that N-heterocyclic carbenes are superheroes, but there are variations, and one of them is a very interesting abnormal N-heterocyclic carbene, which can be synthesized just as readily because the starting materials are the same for or very similar to the regular N-heterocyclic carbenes.